This video will teach you how to decide whether a particular relationship is a function. A function has three parts: an input, which is usually x, a relationship like adding 3 or multiplying by -4 or any combination of operations, and an output. We used to call this y, and based on our conversation the last couple of days, what do we call this now? I hope you remember. Most of the time, we use the letter f to name the function, and so instead of y, our output is called f of x. Here's an example of a very simple function. The relationship is multiplying by 2. So here are the three parts of this function. We have an input, a relationship, which is times 2, and then the output. Notice that this is the function rule. The f of x equals 2x right here. That's called a function rule. And if we plug in our input for x is really just a placeholder for where we put our input. And we multiply by 2, because that's what this function relationship is telling us to do. We get our output. So go ahead and for an input of 50, what would the output be? Well, in this function, the rule is multiplying by 2. So if you have an input of 50, the output would be 100. And this is a function. The following is called a mapping diagram. Let me block some of the screen so it doesn't overwhelm you. So we have these two bubbles, and everything in the first set bubble here, is called the set X. And those are all of our X's here. And this bubble is all of our Y's. And the little arrows pointing from one element in the set X to one element in the set Y, the little arrows show the relationship. It's called a mapping. The formal definition of a function is that it relates each element of a set, so each piece in here, with exactly one element of another set. So each thing in this bubble points to exactly one element in this bubble. Now be careful about what this says, because it says it points to exactly one. But do you notice that this has two arrows going to it? It's important for you to think carefully about what this means. Each element goes to exactly one element in the other set. This points to one element, not two. This one points to one element over here, not two. So you can have arrows pointing to the same thing in this bubble, but not the other way around. Let's take a look and see if we can make that more clear. One value of x cannot map to two different values of y. So 1x can't have two arrows coming off of it. For instance, if this one had another arrow leading to, I don't know, this one. Whoops. If this was leading to that one, that would have an arrow going here and an arrow going here. That's what's not allowed. Okay, so let's take a look at these two and look at the difference and decide which one is a function. I'm going to tell you one of them is and one of them isn't. So look back at the rule, read it carefully. One value of x cannot map to two different values of y. Pause the video and think about this for a second. Decide which one works. Okay, I hope that you took a look. This one, every value of x points to one and only one value in the y bubble. But this one, so this is a function, but this one, the number 5 has 3 arrows coming off of it. This value for x points to 3 different values of y. Not even 2, more than 2. And so this is not a function because that's not allowed. It breaks the rule. Another way to look at a function is by looking at the graph and deciding whether it's a function that way. This way, I got to tell you, so much easier because we have this test to do it. It's called the vertical line test. And the vertical line test, you literally draw a vertical line anywhere on the graph, and this one it's yellow, and if it touches the shape of the graph, whether it's a line or a curve that's being graphed, if it touches it more than once, it's not a function. So you can see that we have this vertical line intersecting here at this red point and here at this red point. It touches twice, so it's not a function. And it's as simple as that. Now I want you to think about that. If every x can only have one y, this point might be the point, I don't know, let's say 3.5 and up 1. This point goes over 3.5 also, but goes up, it looks like a little over 2.5, so let's just say 2.5. Look at our argument here. The same x, but 2 different y's. So if that was in bubbles, I'd have a 3.5 in this bubble, whatever else was in the bubble, and I'd have arrows going to 2 different places. I'd have an arrow going there, and I'd have an arrow going here. And that's not allowed. That's why the vertical line test works. This one is a function. Notice that I can make a line. Let's make like a pink line. And it's vertical. And I can move that line around, and anywhere I move it, it's only going to touch my graph at one place. And so this passes the vertical line test. It is a function. Let's take a look at these. I want you to pause the video and decide for each lettered graph whether it's a function or not. Simply do the vertical line test. All right, take a look. How did you do? The ones with the check marks are functions, and the ones with the X's are not functions. Did you notice that if you drew a vertical line here, it passed through the graph twice, it fails the test. Same thing here. It passes through this oval at 2 places, and it fails the test. But here, the only place it gets close is if I draw a line right on the y-axis, and even then there's no indication that this blue graph touches that line. It looks like it sort of just goes along the axis without touching it in both cases. The last way we're going to look at deciding whether something's a function or not is by looking at just a set of points, ordered pairs. So we have 3 ordered pairs here, and my question is this a function? Does every value of x point to only one value of y? 2 points to 4, 3 points to 5, 7 points to 3. You have a couple of choices. If you're not really comfortable looking at these and knowing whether it's true, couldn't you do a vertical line test doing one little step first? These are points, aren't they? Can you not plot the points on a graph and then decide by doing a vertical line test You could. And the other thing that you could do is draw your bubbles. 2 has an arrow to 4. And 3 has an arrow to 5. And 7 has an arrow to 3. Are there 2 arrows coming off anything here? If there's not, it's a function. And so that's what makes this a function. Every value of x has one and only one corresponding value of y. Also, in this case, notice that our domain is all the input values, the x's, and the range is all the output values, the y's. 4, 5, and 3 are all my y's, and there they are. That's my range. I want to show you another example here so that you can see the difference. If you look at this set of ordered pairs, 2 goes to 4, 2 goes to 5, and 7 goes to 3. I'm saying goes to, sometimes you'll hear maps to. The relationship, whatever the operation is, it's telling you that 2 points to 4. And so either a mapping or a graph, if you sketch a graph of this, 2, 4 would be here. 2, 5 would be here. If I drew a vertical line, even if all I did was graph those 2 points, is there anyone that could argue that this vertical line would pass through both of those points? So this fails the vertical line test because those 2 points lie on the same vertical line. And you could do the bubbles if you're more comfortable with it. So this isn't a function because 2 relates to both 4 and 5, and that's not allowed in a function. So the relationship fails the function test if the same x value points to 2 different y values. And so we had the example where we did the vertical line test and it touched at 2 places, it failed. We had the example where we had the mapping bubbles and the 5 had several arrows coming off of it going to different y values. It fails. And in the last case, we had 2 values of x going to 2 different, or I'm sorry, the same value of x going to 2 different values of y. All of these things are telling you the same things in different formats. It's going to take some practice, and your regular teacher in class will go over this again, but this is a good start to get you used to it.